Hello everyone, I'm Priyanka from Sri Venkateswara College of Engineering from Electronics and Communication Department. The subject is Digital System Design using Verilog, and the topic is synchronous versus asynchronous sequential circuits. First, let's know what is introduction to sequential circuits. Sequential circuits are fundamental components in digital electronics. They operate based on the previous inputs and current state information. Understanding the differences between synchronous and asynchronous circuits, it is essential for effective design. Moving on to the next slide, that is about what is synchronous sequential circuits? A synchronous sequential circuit which relies on a clock signal for the operation. All state changes occurs in the alignment with the clock edges, typically at rising or falling edges. This synchronization simplifies design and analysis by ensuring predictable timing. And the next slide, it is about the key features of this synchronous sequential circuits. Let's know what is key features of synchronous circuits. Synchronous circuits have a global clock that coordinates the transitions. They are generally easier to debug due to their predictable timings. The use of flip-flops is common. It is only common for storing state information in these circuits. Next slide, that is about advantages of synchronous sequential circuits. They offer improved reliability in timing and reducing the chances of race conditions. Design tools and methodologies are well established for synchronous circuits. Scalability is often easier, allowing for larger designs without the timing issues. Next, it is about what is asynchronous sequential circuits. An asynchronous sequential circuit operates without a global clock signal. State changes occur in response to the input signals, making timing less predictable. This type of circuit can respond faster to changes in the inputs, potentially leading to the higher performance in asynchronous sequential circuits. And the next slide, which is about this key features of asynchronous circuits. Asynchronous circuits utilize a network of combinations determined state changes. They require careful design to avoid issues like hazards and race conditions. The absence of clock allows for potentially lower power consumptions in certain applications only, which is belonging to asynchronous circuits. In the next slide, it is advantages of asynchronous sequential circuits. They can achieve faster response times since they do not assign for a clock signal. Asynchronous circuits, which can be more power efficient in specific to low frequency applications. Their design can be more flexible, which can be done any changes which is belonging to asynchronous circuits, accommodating various inputs and timing those sceneries. Comparison of synchronous and asynchronous. Comparing them, synchronous circuits use a clock while asynchronous circuits only relies on input signals. Reliability in timing, which favors only synchronous designs, while the responsiveness of the strength of asynchronous circuits. The choice between the two depends on application, which requires such as speed and power consumptions. Coming to the conclusions and the applications, both synchronous and asynchronous sequential circuits has their own distinct advantages and the challenges. It's like the synchronous has its own advantages and challenges, whereas compared to synchronous, asynchronous has its own different distinct advantages and challenges. The context of their application is crucial for determining the best choice. Understanding their differences helps the engineers to design more efficient digital systems. It helps the engineers to design more efficient systems. Thank you. That is all with this topic. It's just very simple one which I have explained it very briefly. Please do like the video and subscribe to this channel. Thank you.